Well, hello and welcome everyone. Thank you very much for joining. This is our second edition of our Rise and Ignite webinar series. In our previous event, we discussed how companies were and are managing workforce productivity in the hybrid model at scale. However, today we're shifting gears by focusing on data and specifically third generation data architecture. And we've heard through our corporate partners that this is a priority topic for many of your organizations. And it is indeed a very exciting topic that has evolved very quickly over the past couple of years. So in this webinar, we will discuss the trends in data infrastructure, including how the cloud has enabled new and more modern approaches to data analytics and data management. We'll also talk about the evolution from co-located compute and storage to the separation of compute and storage, and then finally the separation of compute and data. So with that, I would like to introduce our next speaker, Tomer Shiran. And Tomer is the founder and chief product officer at Dremeo, where he's led the development of their core technology and has seen the team grow from 10 to over 350 employees. Before that, he also led and held product management and engineering roles at IBM Research and Microsoft. So Tomer, welcome to this webinar and handing it over to you.
All right, thank you, Alberto. I'll go ahead and share my my screen here, and we can get started. So thank you everybody for joining today. So I'm not doing this by myself. It's great to have Michael Flynn here from PwC, and Michael is the partner and data platform leader for PwC, and he'll be talking about the platform that they've built to enable self-service analytics for a very large number of users and data consumers within the company. So just a few words about Dremeo in case you haven't heard of us. Dremeo is a SQL Lakehouse platform. We enable companies to run high performance BI and SQL queries directly on data lake storage. So things like S3 and Azure storage. And the idea really is to eliminate the need for proprietary and expensive data warehouses, and also the need to create BI extracts and really build complex infrastructure. We're used now across all industries, many different customers, primarily the Global 2000, and we are a unicorn now as well. One of the other things we do is we invest a lot in open source, and as part of that, we created a project called Apache Arrow. Early on, Arrow is a columnar in-memory format. Basically, we took our internal format at Dremeo and we open sourced that, working with a variety of different communities. And you can see the graph on the right shows the number of downloads per month of Apache Arrow. So over 60 million downloads a month now. More recently, we created something called Project Nessie, which is a new metastore for kind of the Lakehouse, a much more modern one that enables a Git-like experience where you can create, do version control, create branches and things like that. And then finally, we are the creators, and we host a conference every 6 months, have thousands of attendees in these, called Subsurface. So what we see in the market across basically companies in every vertical is that they, data teams are in this really difficult spot because every company now understands that they need to democratize data, that it will be really valuable if they can put data in the hands of everyone in the company, and that they can, if they can do that with fast time to value, and of course with all the security and governance and compliance requirements that exist today. And you would think that that would be getting easier with time because of all the new technology and the rise of the cloud and so forth. But what we're seeing is that it's actually been getting harder for companies. And the reason for that is that the volume of data has been increasing so fast, and then also the demand for data. So everybody goes to school and learns how to use SQL and how to access data today. And so people don't want to report on their desk on Monday morning. They want access to the database. They want to run their own queries. And so you have this massive demand for data that makes it very difficult for the typically small data team to serve all that demand. And part of the problem is this complexity that typically exists. And one of the nice things that's happened in recent years is kind of the standardization around cloud object storage. So when we think about the cloud, everybody puts their data in things like S3 and ADLS and Google Cloud Storage and these object stores that are infinitely scalable, very inexpensive. They're always on. They're available in many regions. But historically, we haven't been able to query that data fast enough and easily enough. And so subsets of the data would get copied into, a data warehouse. And from there, often we'd have to create BI extracts, things like Tableau extracts, Power BI imports. You have to create derivatives within the data warehouse. And then also, things like cubes. And so you have all these different copies and permutations of data that are being created, this really complex ETL pipeline. And the result of this is not just that you have this expensive and hard to manage infrastructure, but more importantly, that users can't do things on their own, right? When the stack is this complicated, there is no self-service. Everything is an engineering project, every change that you want to make. And what we hear is that it typically takes weeks or months for a request from an analyst to be turned around. So, whether it's wanting to add some new data to the system or wanting to change something in a dashboard, it becomes a hard thing to do. And our goal really is to minimize complexity, right? Because if you can minimize complexity, you can then start to empower these users, whether they're BI users or data scientists, to have access in a self-service way and to be much more agile. And how we've done that is through a number of different kind of innovations around, building a really high performance SQL engine, introducing query acceleration technology, providing a semantic layer as part of the data platform as opposed to within each of the different BI tools that are being used. And the idea here is to create this kind of no copy approach, right? Being able to query the data directly. The reason we think about this as the third generation architecture is because if you look back in time a little bit, and let's say we go back a decade, we were all talking about the co-location of compute and storage, right? So you think about kind of the on-prem data warehouse, right? It was all about, I had a bunch of servers, and on them we had the storage and the compute all running on that same kind of cluster. And the same was true if you had a Hadoop cluster on-prem. You basically had one kind of monolithic stack, all these open source projects all running on the same hardware, both the storage and the compute. And if you wanted to expand one of those, you kind of had to just add servers, which would add both storage and compute kind of hand in hand. And one of the cool things that happened, starting around 2015, is this notion of separation of compute and storage, which was made possible by a new architecture of cloud data warehouses, right? Things like Snowflake, Redshift, Synapse, and so forth, where the data is stored behind the scenes in something like S3, and then the compute can be scaled independently from that. And that brought various advantages around, especially efficiency and being able to start smaller and things like that. But really didn't change what was possible because the data was still kind of isolated to that one single engine, right? If you wanted to use a single data warehouse, you had to first put the data in that data warehouse in order to really use that data, at least with kind of any reasonable performance. We're now going through as an industry this shift to this new architecture. Some call it a data lake house, some call it a cloud data lake. But fundamentally, what it's about is making data its own tier, right? So the data now, rather than being tied to one single compute engine, is stored in the company's own cloud account and in open source formats. So you have file formats like Parquet and table formats like Iceberg and Delta Lake, and meta stores like Hive Metastore, Glue, Nessie. All of these are open standards that you can use from any different engine, right? And you see, so this gives you the flexibility to use best of breed engines on the same data. When new things are created in the future, you can very easily adopt them and point them at the data without having to go through a migration process. And so much more cost efficient, much more scalable, and also much more modern, right? This decoupling of data from compute and not just storage from compute. So this is a fundamentally new architecture, and we're seeing this everywhere around us, right? We're seeing the excitement around this new architecture. Bill Inman, the father of the data warehouse, the relational database, embracing this and talking about how this is the future. Werner Vogels, the CTO of Amazon, talking about why Amazon internally uses this architecture for their own internal analytics, right? And we actually have had the pleasure of working with the teams at Amazon.com using running their dashboards on top of Dremeo, and so we've seen this firsthand in these some of these most innovative companies. You see here an example of a post from a data engineer at Apple talking about how they're able to take advantage of this type of architecture, kind of the no ETL solution, right? Where you have a standard data tier that you can use from many different engines, right? And Dremeo, we provide the SQL option, but there's engines for all sorts of different types of workloads. And then you see Gartner talking about how that they call it the zone of confusion between the warehouse and the lake, and how what was historically the data lake technology has been growing in terms of its kind of use cases and really taking over a larger portion of workloads. So what we've been focused on is making BI work on data lakes. That's a really important workload, of course, for the enterprise. And the way we do that is through a number of kind of key innovations. It starts with really providing that kind of performance, right? This is a blog post from the head of Power BI at Microsoft talking about how we together enable very fast kind of BI on top of cloud data lakes. But that's a result of things like a kind of a columnar cloud cache that provides local NVMe performance, even when you're accessing things like S3 and Azure storage, things like reflections to provide orders of magnitude speed up. So all these different acceleration technologies that make it so that you don't have to copy data into a warehouse and then create BI extracts and things like that. And then self-service semantic layer. So providing a self-service experience to users, providing a semantic layer that gives them the same view of the data, regardless of what tool they're using. So some people using different BI tools, others maybe using data science tools, maybe writing SQL queries by hand. So having this kind of shared semantic layer, shared view of the data, where all the security is applied there and the kind of the KPIs are consistently defined, it provides a lot of value when you're creating this kind of centralized platform. Being able to isolate different workloads. So the CEO's dashboards, really shouldn't be impacted by a team of data scientists that is running maybe more exploratory and complicated SQL queries. So having different engines with automatic query routing to these different engines enables you to do that. And then an open data architecture that provides things like transactions and DML operations and multi-table transactions with things like Project Nessie. All of these come together to enable kind of a new kind of experience that in the past was just not possible on data lakes. So with that, I want to invite Mike here to share how they built their data platform, and maybe Mike, if you can start by telling us a little bit about kind of your role within PwC and about the platform that you've created.
Sure, thanks, Tomer. So I'm a New York-based partner at PwC. I've been with the firm for quite a while. Traditionally, kind of a financial services background, but about 3 years ago, I got asked to take on a role of helping our firm build what we titled our next generation data platform. And it's interesting as I listened to your presentation is we actually have a twist on the problems that you were kind of describing, which I can essentially summarize as you can think of it as massive federation in terms of the people that are actually doing the workloads like you described, as well as the fact that the majority of the data that we care about does not originate within the four walls of our company, right? We're a professional services organization, and we're getting data from our clients, and we have many engagement teams, like at any given point, probably 30,000 engagement teams that want to do something with that data, but it's all different pockets of engagement teams. It's not part of kind of like a big central kind of corporate data set. So that presents a set of unique challenges that I would kind of summarize this way is we had multiple tools that our teams were using, completely different kind of across the globe. And there wasn't really something that could stitch together and tie together and make it easy for people to use different tools to, for example, acquire data, then analyze data, then visualize data, then share that data back with a client, all seamlessly and kind of all with like what I would call like a common key, right? That's more than just an identifier, but kind of a consistent way of accessing and dealing with that data. So that was really kind of the problem we were trying to solve. And I'm going to break down this picture that I have on the screen here as global kind of distribution of both our clients and the teams that are going to be supporting them. And we really built out three kind of capabilities that we call the data platform. One was a set of accelerators around helping teams, build things like, faster application development, et cetera. I'm not really going to cover that today. because it's not really as applicable. But what I am going to cover is really how we thought about data management, and then this concept of a workbench, which is where our engagement teams go to do their work, and really how Dremeo helped us, kind of meet the vision that we kind of had, all with an idea at the end goal is to get to a business outcome, right? And those business outcomes are obviously, domain and, sector specific, but a lot of the underlying kind of needs were the same. So Tomer, if you could kind of flip to the next slide. So kind of, again, setting the stage of like, what is the data platform? As I mentioned, we have, all these sources that are coming in really that are impossible to predict what our engagement teams are going to be wanting to get. It could be ERP data, it could be sensor data, it could be coming from a cloud data, capability, subscriptions, et cetera. And we go through like what I would consider a relatively normal kind of data pipeline around, capturing the data, ingesting it, virtualizing. As you can see, I have that one in red because that's really where kind of the virtualization and storage is where we found a lot of value and benefit with Dremeo, where we're using kind of, cloud native storage. In our case, it's ADLS to store the data. But then how do you give people kind of access to the data? So now I have this data, it's virtualized. I've enforced, standards around governance, metadata security, cataloging. But we're doing this over and over again in the concept of this thing called a secured workspace. So what's a secured workspace is, let's call it, 1 to n number of practitioners, probably on average, it's less than 20, that are all going to be on an engagement for a client. And they're going to want to have access to the data that's part of that client. But we don't want anybody else to have access to that. And so it needs to be kind of limited. But at the same time, and this becomes a little bit of the trick, is let's then pretend that I'm doing another engagement for that same client, and I want to be able to grant a new engagement team access to that same data set without necessarily mixing the two concepts of the secured workspaces. I need to be able to do that. So kind of have this many-to-many relationship between data sets, what's driving kind of the virtualization and the access of those data sets, and then the engagement that we wanted to be able to do this. So, this entire this whole ecosystem that's running here is running in this concept of a secured workspace. So originally we started with Tomer and team. The idea is that we were going to have an instance of Dremeo for each secured workspace that would then provide all of the different tools that our practitioners wanted to use, or maybe not all of them, the majority of kind of SQL-based tools that our practitioners wanted to use, access to that data for them to do their analysis, their visualizations, their sharing. But what we ran into is, and if you go to the next slide, Tomer, what we ran into was the fact that, it was a cost benefit of, we have a lot of very small workloads, and I don't mean small from a data set size, but small from the number of users that want to run a query or the amount of queries that they're running at any given time, relative to having kind of like a standalone instance of Dremeo to be able to provide that. So what we did is we wrapped an additional layer of kind of abstraction around it, where rather than having an individual Dremeo cluster for each workspace, we do it now on what we call a restricted segments environment. So you can think of this as things like, we're really a firm of firms. So, whether it's territories or whether it's lines of services, whether it's the idea of separating our deals business from our accounting business, from our tax business, each one of those businesses essentially gets their own kind of, essentially infinitely scalable Dremeo instance that allows us to, if you go to the next slide, Tomer, to get to really the point of what I was trying to make. And so on this slide, if you look down at the bottom and you look at each one of those secured workspace containers, you'll notice that they're color coded. So each one of these Dremeo instances up on top are auto scaled. But to Tomer's point around separating kind of data from storage, our data is being stored kind of within this, below this data storage control plane that I've labeled it there. And what that control plane does is it allows me to essentially instantiate a storage container within a Dremeo instance to make it available to an engagement team within that kind of restricted segment environment. So you could think about like the picture all the way on the left of Dremeo was like, that's our deals business. The next one would be our tax business. The next one would be our consulting business. And what you can see is I can mix and match data sets to allow engagement teams to be able to access data sets. Usually if it's client data, it's only going to one engagement team. But this also allows me to do things like let that engagement team or multiple engagement teams, access commercial or third-party data that we're pulling it in, and being able to, essentially abstract and allow us to also scale these instances such that anybody can really have, this is a many-to-many relationship between these Dremeo instances and the underlying storage that's holding all of the data that we have. And so, essentially coming out of this was the architecture that we use to maximize, one, the flexibility of Dremeo in terms of, again, handling, up to 30,000 different engagements at a time that we essentially wanted to completely isolate and give them the ability to do Dremeo, but to do that in a cost-effective manner. Excuse me. And this is how we kind of did that, Tomer, if that makes sense. And some of the reasons, again, for the multiple Dremeo instances, we've been asked, why couldn't we have done this with just one instance of Dremeo? And the answer from our perspective was, number one, we wanted to be able to segment users' roles and fine-grained access control kind of by business units. The second of, we did run into some limitations about the number of data sources that any one of these instances of Dremeo can kind of deal with and manage and memorize. So it wasn't really like a scaling problem. It's more like a number of pointers problem. And then the final reason was this made it super easy for us to be able to charge back our engagement teams in terms of managing the actual compute resources that they're using.
And I know you use the term citizen developers to describe kind of many of the users of this platform, and kind of what was the value kind of to those types of users?
Yeah, it's a great question, Tomer. So you mentioned something on your earlier presentation around enabling the SQL user. And part of our corporate strategy over the last few years has been something called our Your Tomorrow strategy, which was really about upskilling all 50,000 practitioners in the United States from a technology perspective, teaching them how to do analytics, how to use visualizations, how to use automations, et cetera. And what I would say is I think historically, when you're talking about large data sets, or really any data sets over a reasonable kind of Excel managed size, what you get into is the tools that are available are kind of SQL, which I think most of our practitioners are capable of getting to, or you're looking at using something that's more complicated where it takes more of like a programming, or at least like what I would call like a highly advanced background. And so what Dremeo did in kind of the SQL, like the premise of starting with SQL is it made it simple enough for this to be broadly available and applicable for the average user to be able to use.
Cool. Thanks for sharing that. That was super interesting, and it's been great to partner. So let me now stop sharing here, and we can open it to some questions from the audience.
That sounds great, and what a great discussion. So yeah, thanks everyone for also submitting your questions in advance in our registration page. We'll do our best to address as many as possible as we can right now. So maybe I'll start with you, Tomer, for our first question, and maybe just to make sure that we're clear on our data terminology. If you can please explain the main differences between a data warehouse, a data lake house, and a data mesh.
Okay, that's a lot of options there. The data warehouse is basically a relational database that you put the data into the database and then you can query it, right? And actually for many years, people used just, their Oracle or SQL Server database as their warehouse. And, then there were more specialized ones, and you have that in the cloud with Redshift, Snowflake, et cetera, Synapse. A data lake is, and kind of a data lake house I see as the evolution of the data lake, really to include more functionality and to really be able to do more of those workloads that maybe traditionally did require a relational database. So a data lake is one where you have that kind of open architecture. The data is its own tier, it's stored in open formats, can be accessed by a variety of engines. Data mesh is another term that is more, I think, more abstract. It's less of a, it's less of a, a system or an architecture. It's, I'd say, more of kind of an approach or an idea. And actually, a lot of what you saw here from Mike was exactly that, where you have different teams kind of with their own data, kind of managing their own data separately. So that's really the idea behind the data mesh. It's just, is more organizational, like how do you work? But that can be done, and is typically done with kind of a data lake or lakehouse type of solution.
Thanks, Tomer. Mike, I would like to ask you the next question from the audience. And this is, what were the motivations to implement Dremeo, and what has been the main benefit?
So the motivations were, I think, threefold. Number one is, as I mentioned, we have a ton of small, and again, when I say small, I'm not talking about a size. What I'm talking about is, I don't have, or the problem we were trying to solve was not like, how do I deal with all of my financial data for my firm, right? Where it's internal, I'm dealing with something very specific. And not that, you know, Dremeo might not have been the use case for that. I think it's what Tomer kind of covered. It wasn't really our use case. Our use case was, I have data coming in from clients all over the place, and I have to try to bring data together with practitioners in a manner that's, you know, repeatable and scalable. And what Dremeo allowed us to do, and that was kind of the point I made on my last slide, is it allowed us to abstract that access control in dealing with that data from the data itself, such that I can mix and match essentially access and data sets without necessarily having to compromise the data, move the data, you know, copy the data, et cetera. And yet I can still let multiple different groups of people you know, do analytics on that data to derive and solve whatever problem they're looking to solve. So that was really the benefit that we got out of it. And as I pointed out, you know, as we were looking at this, there's definitely a little bit of art over kind of science in terms of, if you do want to have multiple instances of Dremeo, what's the right way to do it? And I will tell you, working with Tomer and his team, it took us about a year to really, I think, nail the right mix of, you know, trying to abstract that out kind of infinitely. And then you're essentially paying a cost premium running a relatively small cluster versus, I think, where we got to now, which is the right balance between the two.
Thank you very much, Mike. Great. So our next question is again for Tomer. If you can share some practical advice on how to build a semantic layer in the organization to get rid of silos, and what would be your approach to do that?
Yeah, this is where it kind of depends on the organization, because for some companies, it's all about unleashing the users and letting them do whatever they want, right, with data. And then for other companies, the IT team wants to have a lot of control and make sure that everything is very tightly governed, and you know, you can only query things that have been kind of approved by, you know, in terms of data governance and so forth. But what I do strongly believe in is that the semantic layer for a company needs to be in the data platform, right? Like if you start doing that one-off in every single BI tool, and you know, typically you have hundreds of each of these BI tool instances as well, then it's very hard, because you know, permissions don't travel with data. The definitions, the calculated fields, the you know, the virtual data sets, they're not consistent across different parts of the org, and very quickly you have you know, inconsistencies, right? What is a work week? Is that Monday through Sunday, or you know, Saturday, or Monday through Sunday, or Sunday through Saturday, right? You know, who should see what data? By being able to do the semantic layer in the data platform, you can then basically show everybody the same view of the data, regardless of what tool they're using. So I think that's important.
Great. Well, we ran out of time, even though we have some other questions. But with that, I want to thank you very much, Mike and Tomer, for joining us today. And one final thank you to all of you on behalf of Insight Partners at Insight Ignite. I hope you have a very nice day, and we look forward to seeing you again in our next Rise and Ignite event. Have a good day, everyone.
Thank you.
Thank you.